Hello everyone, hope you're doing really good and welcome back to my channel. Today we are at day 6 of the July Day Leetcode Challenge and we again have a medium level question in front of us. It's again slightly different from what we have in the previous days. Let's see what the question is. It's question number 209, minimum size subarray. Okay, minimum size subarray. So what is the difference between a subarray and a subsequence? These things we have discussed many times in previous problems, so I will not do that again. But if you have a doubt, what is a subarray, what is subsequence, please go and Google it once. Definitely will get some ideas, right? In this case, we are talking about a subarray. Subarray is basically a portion of an array. Okay, a real portion of an array. Okay, it should be integrated portion of array, right? We'll see that. So what you can see, what are the inputs given to us? We are given integer target, okay, and we are given an integer array again, right? So what we need to do is given an array of positive integer nums, okay, and a positive integer target. So one thing is clear, all of them will be positive, okay. That's what they're trying to convey. Return the minimal length of a subarray, okay. See, they are giving a definition of subarray also. A subarray is a contiguous non-empty okay, not subsequent, it's a sequence of elements within an array, okay. For example, what I'm talking about is, see, if you take 3 and 1, okay, you cannot say 3 1 and this 3 forms a subarray, okay. Subarray should be continuous one, okay. So this 3 1 and then maybe a 2, okay. This 3 1 and then a 2 maybe, okay. That's what that is. Subarray is a continuous, okay, contiguous non-empty sequence of elements within an array, okay. It should be contiguous. That's what they're trying to say, okay. Now let's come back to the question. Return the minimal length of a subarray whose sum is greater than or equal to target, okay. Return the minimal length of a subarray whose sum is greater than or equal to target. If there is no such subarray, return 0. What it means is, suppose I select a part of it, okay, its sum should be greater than or equal to target, okay, only then it will qualify. And among all the subarrays which are qualifying, you have to return the one with the minimal length, okay. I hope you are getting what I'm saying. For example, in the subarray, if you see 2 plus 3, which is 5, plus 1, which is 6, okay, 8. This is 8. So this 4 forms a subarray which qualifies, okay. It's greater than 7, okay. It forms a subarray whose length is going to be 8, okay. Definitely it qualifies. Let me check the sum again. 2 plus 3 is 5, 6, 7, 8, okay. 8 is correct, right? Okay, yeah, 8 is correct. So what happens is, now this qualifies. So I can take one of them. The answer is 4. Okay, this says answer is 4. But at the same time, if you see, these two forms are very whose answer, it's again greater than equal to the target, but its length is 2. So basically, the idea is whichever summary qualifies among them all, we have to take the minimum. Okay, that's what it is. I hope the question is clear to you. Okay, till now we are dealing with the question only. We are not going for the core part till now, right? It is the minimum length of a subarray whose sum is greater than or equal to target. Okay. I hope the question is clear now. You have to take a continuous part of array. Take the sum. If it is greater than or equal to target, it qualifies. Okay, it may be the answer, but it may be. Okay, it need not be. That's why you can, among all the such eligible arrays, subarrays, take the length, whichever is the minimum. That is the answer, right? Now, now coming to this question, as I already mentioned, 4 and 3. You see, it's of length 2, and there is no other possibility where no target has been found with a with a length less than 2. Okay, so the answer is 2 in this case. Okay. Now coming to the second example, as you can see, the target is 4. You can see with a single one also I can form a target. So the answer is 1. Okay. Similarly, this number 11, you can try it out for yourself. We cannot form it in any way, so the answer is 0. Okay. So you can see the length is around 10 power 9. Okay. Sorry, the length is around 10 power 5, and target is going to be around 10 power 9. Okay. So now let's come to solution. In this question, what I will do is I will code it in a sliding window approach. I will first explain the approach, then we'll go for the code. Okay, I will be using the queue data structure in it. Okay. What we'll do is, see, the idea here is, please pay attention. Next few seconds are going to be determining what you are going to understand out of it. Okay. See, what I will do is I will keep inserting an element, okay, till it crosses or equals target, till the sum of the queue equals or crosses target. Okay. For example, in this case, I will include 2, its sum is less than target. I will include 3, 2 plus 3 is 5, its sum is still less than target. I will include one more, which is it now becomes 6, its sum is still less than target. I will include one more, now it's become 8, its sum is no more less than target. Okay. Now I will stop. Okay. Now I will stop. I will take its length into consideration. I will update my answer based on its length. Okay, this is what I will do. Okay. Next, once I have achieved a subarray whose sum is greater than or equal to target, what I will do is, once I have achieved it, now I will try to reduce elements from the left. Okay. So for example, in this case, 2, 3, 1, 2 qualifies. I will remove one by one elements. Okay. First, I will remove the leftmost 2. Then I will see if the sum still qualifies for it or not. That's what we're checking. Okay. For example, in this case, its sum is 5, 6, 8. Okay, 8. If I remove 2, it becomes 6, so it doesn't qualify for the target. Okay, what I will do is I will proceed further. Okay, okay, I will just test it. I think that will be a better way to do. Okay, instead of just whatever we're seeing it. So I have just zoomed it. So yeah, this is the one. Okay, initially we have 2. Okay, it does not qualify. Similarly, we have 2 plus 3, which is 5. Okay, 2 plus 3 is 5. Then it becomes 6. Then it becomes 8. Once it becomes 8, it qualifies. Okay, because 8 is greater than or equal to target, so it qualifies. So we have to consider its length as one of the possibilities of answer. Okay, 4. Okay. Now I will try to remove one element from the left. Okay, then try to see if it still qualifies or not. If it doesn't qualify, don't do. If it qualifies, then remove it. Okay. So what I have 8. 8 minus 2 is 6. 6 doesn't qualify. 6 is not greater than target, right? So do not remove this element. Okay. Simply add the next element to it. Okay. I am simply adding the next element, which is 4 in this case. Okay. So what happens? I had 8. 8 plus 4, it becomes 12. Okay. 12. The answer is 5. It is again a valid option for answer. Let it be. Now what I will do is, since it's qualified for the answers, I will again try. I will check if I remove this last two, it will still qualify for the answer. The sum in this case is 12. Okay, let me check again. 5, 6, 7, 8, and yeah, it's 12. I will just try to. I will check if after removing the leftmost element, if it still qualifies for the greater than target criteria, right? So yeah, 12 minus 2, definitely it qualifies. So I will remove this two first. Okay, it remains like this. Remember, after this stage, I have not added a new element. Okay, instead I have removed the leftmost element. Okay, I have removed the leftmost element. Okay, so what it becomes, 3 plus 1. Okay, 4 plus 3, 7, 8, 9, 10. It becomes 10. 10 still qualifies for the target. Okay. Remember, this array is also subarray. So we have to take this length also into consideration. Okay. It's still greater than or equal to target. Then I will check to see if I remove this element. Okay. If I remove 3, is it going to be greater than or equal to target? Okay. It is. Okay. 1 to 4, if you take the sum, it is still less than or equal to target. In that case, I can remove 3 also. So I will remove 3 now. Okay. You have to see in each of the cases wherever I have mentioned this length, right? These all cases qualify for the answer, right? For example, still whenever the case has some greater than equal to target, every such case we modify. Okay, so where we are, yeah, we are here. 1 to 4, and still it qualifies for the target. Now comes to the next case. If I remove this one, okay, it becomes 4 plus 2, 6. 6 is not greater than equal to target, so we need not remove one. Okay, leave it like that. Okay, now I add the next element, which is the last element, which is 3. Okay, I add 3. Definitely it qualifies for the target because sum is greater than equal to target. Its sum is 4. Sorry, its length is 4. Okay, what is the sum? Its sum is 3 plus 3, 6, plus 4, 10. Okay, definitely I can remove the last element. I remove it. It becomes 2, 4, 3. Okay, what is the sum? It's 7 plus 2, 9. Okay, 9 definitely qualifies, right? Length is 2. Now I will try to again remove the leftmost element. Okay, it becomes definitely, after removing it, the sum is definitely greater than equal to target. Remove it, it becomes 4 and 3. Now answer is 2. The length is 2. If I remove 4, will it qualify? It won't qualify. So leave it like that. Now the array ends because there is no more element to be inserted. So I hope you understand my approach. So what we are doing is, see, for example, in this case, when it qualifies for the answer, okay, when it qualifies for the answer, what we'll do is we'll try to remove the leftmost element. Okay, see, till now what we're doing, we are adding one by one element because it sum was not till greater than target. Okay, till greater than equal to target, till then keep adding element. Once it becomes greater than equal to target, the sum becomes greater than equal to target, what we're going to do is remove the leftmost element. Try to see if we can remove the leftmost element and still the sum can be greater than equal to target. Do that. If it's not possible, no need. Simply proceed with adding the next statement. Okay. Here, that's what I did. See, if I remove 2 here, it sum will be less than equal to target. Okay. Its sum will be less than equal to target. So I need not remove it. Okay. I should not remove it. Instead, I can add the next element. Okay. Now I have added the next element. I will again check if I can remove this 2 and still the sum can be greater than equal to target. Yes, it is in this case. That's why I remove that 2. Again, I will check if I can remove this 3 and still the sum can be greater than equal to target. Yes, in this case it's 2. So I will again do that. It was 1 to 4. Now, if I remove 1, it won't be greater than equal to target. So leave 1 like that. Now add the next element. Okay. Now I will add 3. Same thing I did. Once I add it, I will again check if I can remove the leftmost element and some can be greater than equal to target. I again did that. It became 2, 4, 3. Again, I remove 2 and become 4 and 3. Okay. After that, I don't have any element to be removed because I remove 4. It won't be greater than equal to target. Similarly, I don't have any element to add. So the loop will end here. And among them all, whatever you are seeing here on the right side, among them all, the smallest will be the answer. Okay. In this case, 2 is the answer. That is what my solution is. It's going to be a sliding window solution with the help of a queue data structure. Okay. I will just zoom out and I will again go through the code. Okay. So we are going to use 3 variables basically here. Okay. One is the queue itself, because for queue I have to maintain data structure, right? Because which element to be popped out, Okay, that will be determined by this queue. For the first in first out approach will be followed. Then I have a queue sum. See, instead of calculating the sum every instance, we can reduce that processing time by maintaining a queue sum, because see which element is going to be inserted and which element is going to be removed is already predetermined, right? That's why we can follow a definite procedure by maintaining a variable. Similarly, for maintaining the queue length, see, I need not calculate the length every time. Okay. See, remember, whenever you use the length function, len function in Python, that also uses some complexity, right? They also use some time complexity. So we need not do that every time. We can simply use this. Okay. Next, I will have an answer variable which I will be initializing with the maximum value of a float. That is the infinite value of a float. Why I am doing that? Because remember, I have to return the minimal length. Okay, I have to return the minimal length. Okay, that's why answer will initialize with infinite value of float. And at last, I will check if my float is still infinite. Then I will return zero. That means float has not at all changed. So in that case, I have to return zero. Why? If there is no possible summary, we have to return zero. Right? That's why. And if that is not the case, we have to return the actual answer. Okay. How to find the actual answer? We'll see that. So what are the three variables I maintained? Yeah, the queue itself, okay, the queue sum, and the length of the queue. Okay, then I'm taking the length of the given array also as n. Okay, so I will go through each element of the n. Okay, see, as I mentioned, whenever element comes, first append it to the queue. Okay, first append it to the queue. Okay, add it to the queue sum and increase the length of the queue length. Okay, all these things you do. Okay, then I will check if the queue sum is greater than equal to target. Only if it is greater than equal to target, this much of the code will be executed. Otherwise, we will simply go on and add the next element. Okay. If it is greater than equal to target, what we need to do? First, it qualifies. Okay. Remember, it qualifies. Whatever things are mentioned here are qualified. These all things will qualify, right? So it qualifies. Because it qualifies, now you have to consider its length also. Okay. So what we'll do first, we will update the answer. Okay. Answer is equal to the minimum of the old answer, comma the current length of the queue. Okay, that's what it is. Next, I will check till queue is not empty. Till queue is not empty. Just what you need to do is queue sum, which is the sum of the queue minus the leftmost element of the queue. Okay, queue sum is the length of the sum of the queue elements of the queue minus the leftmost element of the queue. If I do this minus, if the target is still that, if the sum coming is still greater than equal to target, if this is the case, that means I can remove the leftmost element. Okay, I can why I have written this here to ensure, see, we are accessing queue of zero, right? That should be element. If there is no element, I cannot access queue of zero, right? For that, to ensure that this error doesn't happen, I have written queue here. Okay, if the queue is empty, I will not go for this. Okay, so if I subtract the sum, if I subtract the leftmost element of the queue from the current element sum, if it is still greater than equal to target, I'm checking that. If it is still greater than equal to target, remove the leftmost element. That is, remove the zeroth element. That is, pop out the element. Okay, pop the first element out. See, that's why to make to have you guess the correct answer, I have given the naming conventions also properly. See, I have meant written here as q. Okay, q basically means that the first one should be first out. Okay, that's what is happening here. The one which is in the zeroth element will be removed first. Okay, yeah, so that will be subtracted from the q sum, then it will be popped out, and then the q length will also be reduced. Remember, because these after even after subtraction, that is, even after I remove this element, the sum is still greater than equal to target. That means I will again check if I got a new answer or not. Okay, as you can see here, we may get the answer at any step, right? That's why I will check at that again. Again, the same thing. Whatever code I written here, right? Yeah, this thing will again come here. Okay. So remember, this is a while loop. This is not a if condition. This is a while loop. This loop will continue. That means till I can, I will try for all the leftmost elements till there is a case where the sum is not, after subtracting it. That is, after popping it out, the sum is less than or equal to target. Till that condition, I will be popping out. What happens is, see, I will again repeat. For example, see, I have 2, 4, 3. Right? If you take its sum, which is going to be 7 plus 2, which is 9. Okay. So in this case, what happens is 9 is definitely greater than or equal to 8. Right? So it will enter this. It will enter this thing. Okay. It will enter this thing. Then what will happen is, I will try to remove the leftmost element. Okay, see, because 9 minus 2 is 7, right? 7 is greater than or equal to target, right? So these two can be removed. So, okay, I will remove it. Then it becomes 4 and 3. Then I will update the answer. Okay, so this is also valid condition, right? So I will update the answer. So this becomes the answer. That's what I'm doing here basically, right? What happens is, I will again repeat. First, whichever element comes, insert it in the queue, update the variables. Okay, add it to the sum and add the length by 1. Okay, then check if the QSUM is crossed. Okay, if the target is crossed, if the QSUM crosses the target, then we have a probable answer. So update the answer variable. then then we will start looking at the leftmost integer. Okay, leftmost integer of the queue. Okay, if after removing that, that's what we are checking here, right? If I remove that, will the sum is still greater than equal to target? If it is, then remove it. Okay, and update the answer again. Remember, it's a while condition, so still it is possible. It will be going on. Okay, it will be going on. And finally, we'll come out of this when then we'll add the second, the next statement, and so on. It will continue, right? So after we come out of this for loop, we will see this condition is for checking, because see, we started with infinite value, so we are checking here if the value is still infinite. That means this condition never got executed. Okay, this condition never got executed. So in that case, we have to return zero, because there is no such subarray which has a sum of greater than or equal to target. So we have to return that. And if that is not the case, if this is not the case, where answer is not equal to float of infinite, that is, this condition got executed at some instance or the other. Yeah, that means we'll return that answer, the smallest answer. So yeah, often this was the sliding window approach using the queue. Okay. So when we say sliding window, see, you queue or stack, these things are on your own, depends on your technique or what question it is. But yeah, it's up to you. And see, I've tried my best to show you the tracing part here, the dry run part here. See, these things matter a lot in interviews. Okay, what you're thinking is, see, basically, if you say verbally, the interviewer may not understand. Okay, you it obviously depends on your communication skills, but still, I will suggest that always do this kind of dry runs. It helps you also to trace. You will find the minor mistakes here. Okay, so I also did the same. Place it here. See, this part is the Q part, and this part is the length part. Okay, for these things, no need to mention length, because these do not qualify for the answer, right? So I did not mention the length. From here, it qualifies for the answer, so I have mentioned their length onwards. Okay, so that's what it is. So yeah, fun. That was all for today. This answer is nearly 50. Okay, I will run and show you this answer nearly 50% faster. Yeah, as you can see, it clears the test cases nearly 50% faster. So yeah, fun. That was all for today. If you have a better solution, please do comment below. We can discuss it further. And yeah, thanks a lot.